Why don't we get started? Thank you for coming and attending. This is a project on air quality management data systems, and it's a report out on some work that we've done to look at what are the needs out there and what would an ideal data management system for air quality be, both focusing on the people and the software, and then talk a little bit about the next steps. The team here, and this is work that's been funded by the Clean Air Fund. And my name is Tim Dye. I'm from TD Enviro, and we also have colleagues on from University of Massachusetts and Valiant Solutions, and you're going to be hearing from them a little bit later. The way that we've structured this is we have intro and objectives in the Clean Air Fund. Shahram from the Clean Air Fund is going to talk about that. And excuse me, let's see. And then I'm going to talk about the summary of work, and Rick and Kristen are as well. We're going to do that in all in about 25 minutes or so. And then we're going to have time for an open Q&A and discussion about the results that we're presenting, and anxious to hear and excited to hear some of the ideas and thoughts and questions that you all have. In terms of the table of contents, the Clean Air Fund and Shahram will talk about the context, why this work is being done. I'm going to cover the key findings. Rick is going to cover the ideal data management system, and Kristen as well. And then I will come back in at the end and talk about next steps. All these slides are available. They'll be made available to you after the webinar. So with that, Shahram.
Thank you, Tim, and thank you, everyone. I'm Sriram from Clean Air Fund. I'm a senior specialist supporting the data portfolio of Clean Air Fund. A brief background on Clean Air Fund before we get started. We are a UK-based global philanthropy working since 2019. We are currently supporting clean air initiatives in UK, Eastern and Southern Eastern Europe, Ghana, and India. We'll be soon be making grants in South Africa as well. Apart from the national work, that's happening through our global portfolio, through our country-wise portfolio. We also global portfolio work through our thematics, data being one of them, health and private sector are other two thematics, where we support initiatives globally. Next slide, please. Thank you. A quick background on the scope of the data strategy before we understand why this work is very relevant to us. So our mission is to strengthen the air quality data globally. Thus, we have identified 4 work streams through which we support this work. They are increasing the amount of local air quality data through monitoring, such as investing in initiatives such as Breathe London, or programs to support initiatives that will help in uptake of small sensors, or investing in innovation that can help understand emission and sources that can be led to development of tools that the cities and the states or the countries could use in understanding the emissions. Data management system is one of the such initiatives which we think that will help in making the global data consistent and accessible to all. And we also support a lot of other local and global capacity work on air quality data management. Next slide. So, so the context on why we started this work. So at Clean Air Fund, our belief is that it centers around the idea that by generating substantial amount of data on clean air and its impacts on health, we could use those evidence in delivering information to the right individual, and that can significantly contribute to achieving clean air globally. Through our strategy and global acceleration on air quality data, we've identified that this data management is a major issue. As you all know, that investing in generating data will lead to a lot of data that is then will be difficult to manage. We are moving in the right direction, but handling of data is also important, which we feel like it's becoming a trouble to many cities and countries that are trying to manage, develop evidences and take initiatives. Data management is also expensive. So the process of effectively managing the data has emerged as a complex challenge which requires both data, time, and resources. We're also coming across this as an issue in our grant making areas as well, where cities are trying to amp up their monitoring, but they're also getting burdened by managing the data or using that data to actually take action. So in some cases, we've also noticed that because of this issue, the work is getting delayed, or these cities are diverting their resources into developing their own data management uh, software or a project where this resource could be used in actually solving issues on the ground. This has also led to duplication of resources from our end, from implementation point of view as well. So we wanted to find a simple solution that can help in building a system that everybody can use. And in many cases, data generated is also not used properly or properly acknowledged by the policymaker due to its quality being an issue. Thus, we commissioned this assessment to understand and engage with the international air quality community to see what is the best way forward. Next slide. So this work, the scoping exercise, try to understand what are the unmet current and future requirements, and what would an ideal data management system should look like. Through this effort, we'll be able to identify opportunities that can help the communities and also the grant making perspective, so that we could find a solution that is sustainable for the future needs uh, for the people from the top to down. With that, I will hand it over back to Tim and team to talk about the findings and take you through the next steps.
Great, thanks, Sharon. Let's see. So when we think about a data management system, we think about kind of a network of networks. And I'll talk about the DMS in a minute, just kind of how we envision that. But we see a DMS as being able to run locally and bring in data from maybe reference stations, or over here on the left, a DMS could be run locally and bring in air sensor data and reference data. Or down at the bottom, a DMS could bring in data, not run any sites locally, but bring in data from other sources and integrate that into data and manage that, view that, distribute that. So we really see this more as a system of systems, not necessarily one kind of universal DMS, but a DMS that could be run in a variety of different locations and installations. In terms of what a data management system is, it's really a collection of hardware and software, and receives data from a variety of different instruments and different types of data, and then does a series of things: ingests that data, stores and processes that, distributes that. Underlying all of that is people. There have to be people with a staff with skills to operate and maintain that, and then data are distributed like I showed in the previous slide. Integral to this is support and training and some sort of broader community of practice. And speaking of community and practice, and you'll hear this kind of again and again throughout our report out, is this is important, and one of our key findings. Community and practice is really a domain, an area that's shared. In this case, it's air quality and air quality data management. It's a community of people where building relationships through discussions, interactions, trainings, webinars, and learnings. And they've established some sort of practice, a routine meeting. They have some methods to share either software or share stories or interactions. And we bring this up because you're going to see a little bit later that this is an important element when we start to think about the ideal DMS. So the next thing I want to do is report on the key findings from our assessment. We had 7 insights on what is needed. This was one of the quotes that we got, and it said, if we could figure this DMS thing out, and it's easy to use, relatively inexpensive, and sustainable. Okay, that's a lot, but given that, it could make a huge difference in the outcomes that we want to see. And so I think that's interesting to see, because they're saying like, we need this. And if we can make it easy and relatively inexpensive and sustainable, this is going to be really beneficial. And indeed, that's one of the things that we found. Our first finding was DMSs are urgently needed. Many organizations, in fact, almost 70% said that they urgently need a DMS. And a DMS is going to help these organizations focus more time and money, not on building the DMS or sustaining it, but more time and money on action. And that becomes, really important as we start to think about how do we transform data into action, and spend less and less money on managing data and more money on how to interpret the data, what to use, and what actions to take. And Shahram talked about that a little bit earlier. Our second finding was kind of interesting. Standard features will meet most needs. Users said we don't need lots of fancy customizations. They're nice, but we don't need that. Typical DMS. And those features, some of the very important features were data harmonization, where we're trying to think about what are the formats and the metadata. And I'll talk about that in a couple of slides as well. QC tools, especially calibration tools, as we bring in new devices like lower cost air sensors and other equipment that requires calibration. Some data aggregation, data security, thinking about how data get distributed and who gets that data and how that data can be shared, and some basic visualization. Not the advanced stuff, but some basics, some line plots and bar charts and some simple maps. Organizations said we're constantly reinventing the wheel, developing a new DMS, or having a university do that, or having a private company do that, and spending lots of money doing that. So having a standard DMS would really be important. A couple other key things were we need to keep it simple and not overly complex, especially for low capacity environments. And someone said to us, it's not practical for the DMS to do everything. We don't need it to do that. It should be fairly simple and remain somewhat pure, again, to address this need and also address some of the low capacity environments. And Rick will talk a little bit about users later in regard to low capacity environments. The next finding was open source solutions and options are really desired. People want an open source, low cost solution. That's preferred. Low cost or open source has really taken off in the last, 5-10 years, especially with air quality data management. There's a lot of Python and R programmers out there that are developing software, in open source. A decentralized system would be great that communicates with other systems, like I showed in that early slide, where one system could talk to another. And this open source DMS can run in a variety of different locations. One of the things that we need, though, for this is some sort of seed funding, an organization to help curate the code, incubate the effort, get this going. Finding number 4, data harmonization is a huge challenge and need. This was a recurring theme time and time again when we did the interviews and taught and did surveys of many of the folks across the globe. Data harmonization is critical. There are just too many formats, too many different ways of naming things. There's no consistency in how time is reported, no consistency in metadata. And that makes it hard to integrate data from a variety of different sources. And a lot of people are spending a lot of time trying to integrate that data or not integrate it, and then data go unused. And that's not what we want. So there needs to be a harmonization effort to really make it easier to format this data, describe it, and then ultimately that's going to make it easier to ingest, integrate, and share and use. And so this was finding number 4. Finding number 5 is capacity and training are going to be a big deal, especially with open source software. We need a plan from day one to design training into the plan for this DMS. We need to keep it simple because capacity is a huge deal. And again, we need to think, and we interviewed a lot of folks beyond just the traditional air quality agencies or regulatory agencies. There are cities that could use this, there are academic institutions, there are low and middle income countries that could use this. So in those places, in those environments, capacity and training is going to be a really important thing. In addition, a thriving community of practice is going to help with these efforts, both capacity building and training. Sustainability was a key, and we saw that early on in that first quote. Sustainability will become a critical issue, especially with an open source software solution. We'll need a sustained effort over about 5 years to really get this going, create the DMS, and create a thriving community of practice. In fact, in terms of the survey that we did, the highest response rate in terms of very important, almost everybody answered very important, was funding and long-term stability. And that makes sense. And so we're thinking in terms of like 5 and 10-year time horizons. This is not something that's going to be able to be done in a year or two. In fact, someone said no system should be built without a plan, a 10-year plan to run it. 10 years is a lot. That may be hard to achieve, but certainly 5 years, and thinking 5 years in advance is doable. Finding number 7 is probably one of the most important ones. And that's to create a community of practice and then create the DMS. And originally we were thinking, let's build a DMS and then we can get people to use it. And a lot of people said, nope, you need to reverse that. You need to build a community of practice that's really interested in this, and then build the DMS. And a well-formed and funded community of practice can begin to address some of the challenges that we've identified. What's needed? We need a champion. That could be an organization, that could be a group of individuals to really help set this up and get this going. And so those are the 7 key findings that we gleaned from many interviews that we did and surveys that we did from folks that are using data management systems or would use data management systems. And I really like this one because it kind of encapsulates what I just talked about. If you're trying to stop the reinvent the wheel scenario, then you need to start by building the community rather than build the DMS without the community buy-in, or build the DMS and expect the community to use it. And so we think this really makes sense. And so a lot of it should not be, let's rush to build a DMS and then get everybody to use it. Let's build a community and then have the community and work with the community closely to build a DMS. And what that community looks like, I think, is still to be determined, but we certainly have some ideas and would love to hear your questions and ideas. So with that, I'm going to turn it over to my colleague, Rick from University of Massachusetts, and Rick's going to cover the DMS.
Thanks, Tim. Yeah, so I'm going to talk a little bit more about the kind of granular details of what a DMS is required, what's required of a DMS, including the people and software. It won't be too technical, but I will talk about some of the more details. And as you've heard before, community of practice and users and individuals are actually the underlying component that's the most important part here. So let's start off, next slide, please, by identifying some of the potential users of a data management system. And the findings of this report stratify that there are really 2 groups of users, the initial ones and then perhaps later stage users. The initial ones are low and middle income countries who need a DMS immediately. Some cities who perhaps don't have the regulatory requirements of regulatory measurements also need access to a data management system, and academics. Academics love a free bargain, and so they love to play around. And speaking as one myself, these would be the initial users of a data management system to hammer out the early details. Later stage users involve NGOs and regulatory agencies and perhaps the private sector that could come in later on and continue to develop this data management system as it grows and it becomes more established. Next slide, please. As we've mentioned, the most important part of a data management system actually starts with the community of practice. And that was a bit of a surprise to us that was the order of how things should be developed. But I want to talk about what community practices are and how we can ensure its success. Next slide, please. We identified 5 factors in this project that are critical to making sure that community practices grows and sustains itself. The first is to identify stable funding, and this really needs to be on the time scale of 5 or more years. We need a dedicated champion who can carry this forward. It's either a single organization or a group of individuals, and we have to make sure that champion is the one who can speak loudly and be a cheerleader for a community of practice. We have to address, of course, the key needs of that community and do so in a transparent way. And then, of course, we have to promote this. This isn't something that can just grow by itself. It does need active promotion. We look around the world looking for communities of practice. And, it's not obvious what those communities might be. There are some out there, some examples that we can talk about. Next slide, please. And perhaps the most successful and widespread one is in the air quality world already, and that's the Community Multi-Scale Air Quality System, which manages some of the open source modeling software for US EPA. Its funding line is from the EPA. The champion is the EPA and the University of North Carolina. CMAS actually sits at the University of North Carolina. It meets the needs of the modeling community by including things like training and support, webinars, and some regulatory support as well. It is open sourced and the software is maintained and promotes itself through websites and conferences, workshops, and they've been doing this for about 20 years. Next slide, please. So to identify where and how we develop a community of practice, we divided this into 2 phases. The first is phase 1 that really does require finding that 5-year funding source and the individuals who can help lead it. We're going to conduct a series of workshops, at least that was the recommendation, to further refine and prioritize those needs, to figure out what the different roles and responsibilities and how to make this thing happen, because it is people who lead this and is going to allow this to grow. And then deploy a pilot version of this, a small version with low and middle income countries and academic institutes. Then the next phase, of course, is accelerate the growth to increase the capacity and the durability of such a project, as well as find that 5 to 10 year funding line and expand the community of practice as well, and improve those features and functions that are needed. Next slide, please. Now I'll talk a little bit about the details of how we actually build a data management system. I'm not talking about the technical details of specific software programs or applications, but I want to talk about what a data management system looks like, at least if you were to look underneath the hood. Next slide, please. There are really 3 areas or 3 core functions that are required to operate and sustain a data management system, including data types, data types, DMS functions, and system architecture. I'm going to talk about the first 2, and I'm going to hand it off to my colleague, Crispin Greiner, to talk about the architecture. Next slide, please. For data types, we concluded in this project, that there are really 2 foci of data types that we need to be interested in. The primary focus, of course, are things like basic air quality data and meteorologic data. Air quality data can be continuous or filter-based, speciated data coming from a laboratory, and of course, most meteorologic data is continuous. This can include accepting data both that's directly from a sensor, but also, as Tim noted, from other data management systems that are already in place or in action for specific purposes. We view that there's also all kinds of data that is more of a secondary focus, which would be wonderful to include in kind of future iterations. These include things like satellite data, model output, forecast data, and even mobile data. Mobile data is an important component of air quality monitoring, but it's a different type of data set because it involves that spatial differences as well as a car or vehicle moves around in different locations. Next slide, please. We look at the specific functions of a data management system. There really are 4, as Tim alluded to earlier today. The first is to ingest that data, to pull that data in and grab it from the source, whether it's an individual sensor, whether it's regulatory or a lower cost sensor, or data that's already been ingested from another data management system. So it's sort of a copying of that data. The data then needs to be processed in some way. That includes storing the data, applying quality control to it, validating, and perhaps aggregating the data as well to different timescales and those sorts of things. It's useful to visualize the data in some way. And when we say visualize, we're not just talking about graphical output, but we're talking about tables and reports too. But as Tim noted, that there was limited interest in really advanced visualization. The basic stuff is what was most desired by people. And we would agree with that. And so having a visualization tool in the management system is essential. And then last is distributing that data and getting that data out to the users, because as I mentioned at the beginning, this is the most important part of a data management system are these users who consume and use this data. That includes things like graphical reports and website updates, API calls, all of those different details. And so it's really important that we recognize these 4 functions as core to developing a data management system. There's one extra part that I'm going to pass off to my colleague, Kristen Greiner, who's going to talk about the system architecture of a data management system. Next slide, please, Tim.
Thanks, Rick. As Rick just talked about, the DMS needs to ingest, process, visualize, and distribute data. So we came up with a high-level system architecture for a DMS to operate. Starting at the bottom left of the architecture, first we need hardware, we need computing power, storage, servers, and network connectivity. Next, the data tier ingests and stores that raw data that Rick just talked about. Then if you're following along, working up on our left-hand side of the graphic, the data processing tier harmonizes the data, performs quality checks, and transforms data into consumable data. Then the application processing tier is the underlying backend that makes the DMS function. And the presentation and browser tiers bring the DMS to life, where users can interact with the DMS and visualize the data. Over on the right-hand side of the graphic, we have supporting system security to protect our DMS and our data, and then leverage development tools and processes to enable the DMS to be built and maintained. I think over to Tim to conclude.
Great. Thanks, Kristen. Thanks, Rick. Let's see. So we want to talk kind of final couple of slides here about just summarize and next steps and what's our path forward. So the summary from the work is an open source, no cost DMS is really urgently needed. And to do that, a community of practice will be critical for creating this and sustaining this over time. And some dedicated funding will be needed to form the community of practice and develop the initial DMS. So here's our kind of steps for doing this. Step 1 is to really organize the community of practice. We've got to look around for a strong, dynamic, collaborative community. It's going to hinge on that. There are some really passionate folks out there that are excited about these types of efforts and these types of projects. If you're listening and you're one of them, or if you know of folks, drop their name in the chat. That'd be great to connect with them. But that's the key thing that we're going to work on, is how do we get these people together to begin refining what we found here in more details and begin to build the initial data management system. In addition, I think we found it's really important to secure some longer term funding. While we might get funding for a year to develop initial community practice, it's important to think in terms of 5 and 10 year chunks to really incubate this effort, get this going, and sustain this. That will be absolutely critical. Step number 2, Rick talked about this, is start with a basic DMS blueprint. Create a simple DMS, and that's the purpose. Confirm the confirm the features of that, really through work groups and some outreach. Conduct workshops to further refine that, and then also an effort to harmonize the air quality data is really needed. And that kind of forms the basis for getting this going. Step 3, then create a training plan, as we talked about. Don't build anything without a training and capacity building plan. Had to do that from day 1. Keep it simple and keep focused on those simple features that people want. Shop it around and get others using that. That's a pretty high level summary of the work that we did. I did want to mention that there are a lot more details that are available. We have a summary in more detail, all the findings that I went through, and then the results that Rick and Kristen summarized. We have many more details in the blueprint for a DMS community and the system, where we talk about what is the list of features that are really needed. So that's a quick synopsis of the work that we did. Now what we want to do is we want to open it up to questions, comments, and input from you all. So thank you.